Hey everyone, continuing for asymptotes, we'll be looking at the second one, the horizontal asymptote. And you can probably visualize it. It's basically the y value. An example or generic example would be the horizontal dashed line at y equals to k. Alright, the definition is reversed. So instead of x approaches k, y approaches infinity, it would be as x approaches infinity and or negative infinity, y approaches k. Alright, so this is a definition. It's now different because if x approaches infinity and y approaches k, there will be a asymptote at y equals to k. If x approaches negative infinity and y approaches k, then, well, there will be a asymptote at y equals to k. And another case is if x approaches infinity or negative infinity and y also approaches k, that means the asymptote actually kind of like does at both ends. Which brings me back to the point of crossing of asymptotes. Now, your asymptote won't cross. Your graph won't cross in the long term. And when I mean by long term, it means that at x approaches infinity or negative infinity. But your graphs can cross in the short term. So simply put, if let's say you have the vertical asymptote or horizontal asymptote at, let's say, y equals to 1, and this happens at x approaches infinity, from x approaches negative infinity, or rather earlier, so x can cross, or rather graph can cross earlier. Alright, so what do I mean? Well, let's say you have a asymptote at y equals to k. Alright, in the long term, it will be y equals to k on this side. However, your graph can be look something like this. Alright, on the short term, it will cross, but in the long term, it approaches k. Alright, so it's always focusing on the long-term effect of y, so it still can cross. Alright, so some examples of graphs with horizontal asymptote would be your e power x, right? So the example is e power x, so as you can know, as x approaches negative infinity, it's incredibly small, approaches 0. Alright, so this is one example. The other example would be your algebraic fractions. So let's say you have 1 plus 1 over x minus 1, or actually let's put it more generically, k plus 1 over x minus 1, or even, k plus mx plus c. Alright, basically over your quadratic factors, so let's say x minus 1, x plus 2. Of course, for the last two examples, you have both the vertical and horizontal asymptotes, so do take note. But for this case, your vertical asymptote will be at y equals to k, both will be y equals to k, and of course your horizontal asymptote or vertical asymptote at x equals to 1, on the right will be x equals to 1, and x equals to minus 2. Alright, so why is there a horizontal asymptote for both of these graphs? Because as x approaches infinity or negative infinity, it will be 1 over a very large number. 1 over a very large number is simply a very small number. Same thing for k, plus mx plus c over x minus 1 times x plus 2. Same idea, as x approaches infinity or negative infinity, your denominator will be very large as compared to the numerator. And as such, your fraction will approach 0. Alright, so this approaches 0, this approaches 0, your y will approach k, but you'll never ever hit k. Alright, and you'll never cross k. Same thing, get close, but never intersecting. Alright, just like your crush. Alright, so there we have it, the horizontal asymptote.